Today we're going to look at lines and angles that are formed on shapes. Our learning target today is I can identify parallel, perpendicular, skew lines, and angles formed by two lines and a transversal. Our essential question is what angle relationships are created when parallel lines are intersected with a transversal? Please pause the video so you can fill this out. All right, let's take a look at parallel lines. Parallel lines, we have the symbol of the two vertical lines, and I like to remember that in the word parallel is two vertical lines. So the symbol is also in the word. They are coplanar. So remember that coplanar means together on a plane. And the biggest thing is that they do not intersect. They do not cross. So in the figure, we have line AB is parallel to line EF. So they're on the same side or on the same plane, but they will never ever intersect. Also, we have lines EG on the front are also parallel with FH on the front. Okay, perpendicular lines have the symbol of an intersection with the vertical line and a horizontal line, and they intersect at 90-degree angles. So in the figure, line AB is perpendicular to line AE, and we can put a little box to show that they're 90 degrees. Also, EG is perpendicular to GH, and EG, GH, we can put a box there as well. So far, this should be review. Skew lines might be new to you. They are not coplanar, so meaning that they're not together on a plane, right? So what you need to know is skew lines do not intersect and are on different sides, right? So in the figure, line AB on the top is skew with EG. EG is in the front, AB is on the top back. They are on different sides and they do not intersect. Okay, parallel planes. Parallel planes are planes that do not intersect. So like in the figure plane ABE, ABE, that's the top, right? The top is perpendicular or is parallel to plane on the bottom, plane CDG. Remember to name planes CDG, you only need 3 lines on the plane or 3 points on the plane. Okay, let's practice. Example 1, identify types of lines and planes. So we're asked to find a pair, so a pair means 2, of parallel segments. Now notice that we need to identify a lot of segments in this question and only one set of planes or sides. Segments are part of a line, planes are sides. So a pair of parallel segments. How about, well, it looks like we have a stack of cards. Let's find an easy to see segment like SR. So segment SR is parallel to, well, bottom, front, bottom, back is parallel to segment PQ. All right, let's find a pair of skew segments. So let's start again with SR, segment SR, and well, so we need a different side and will not intersect. So how about this line right here? It's on the back and LQ will never intersect with SR. Okay, a pair of perpendicular segments. So if we start again with segment SR, it's easy to see. is perpendicular to, let's see, maybe this front, we can see that we have that box, which tells us that it's perpendicular, MR, segment MR. Now we need a pair of parallel planes, so a pair of parallel sides. So what if we just use the front and the back, but we need to name them. So the front is plane SRM, and plane, the back would be then PQL. Okay, great. Okay, so let's look at transversal, interior, and exterior angles. So a transversal is a line, and it just intersects at least two other lines. So if we look at line R, we can see that line R only crosses one line. Line S only crosses one line, but line T crosses two other lines. So our transversal is going to be line T. Okay. An interior angles are in between lines R and S. So if lines R and S are here, we're going to say interior angles are going to be anything on this inside or in between. So we're looking at angles 2, angles 3, angles 6, and angle 7. Okay. The exterior angles are then outside of line R and S. So we can color those exterior angles. And then those would be angles 1, angle 5, angle 4, and angle 8 are on the outside. Okay. To practice, we're going to identify, we're just going to label these diagrams. We're going to label which line is the transversal and where the interior and exteriors are. So if I'm looking at which line is a transversal, I see this line on the top only crosses one line, but this line that's diagonal crosses two lines. So that's my transversal. Now I want to think of inside and outside. So inside is going to be like the inside of a sandwich. It's going to be in between two of the lines. So there we have the interior, and then we can label the exterior. Now our two lines cut by a transversal can be rotated. So they might look different, but we still want to find a line that crosses two or more other lines. So we found our transversal, and inside, like inside of a sandwich, that's going to be our interior and our exterior. Okay. Our diagrams can get really tricky. So in this case, we want to identify two angles that we're going to look at. So the two angles, or the angle pairs, are going to be always on my transversal. In this diagram, all four of these lines could be a transversal because every single one crosses two other lines. But in relationship with angle X and angle Y, your angle pairs will always be on your transversal. Then we can look at the interior, and then exteriors would be outside of our parallel lines. Okay, if we do it again on a tricky diagram, looks like all four of these lines could be a transversal, but in relationship to Y and X, your angle pairs will always be on your transversal. And this is going to get a little tricky, but I'm going to follow my transversal on the inside. So then there I have my interior and my exterior. It really helps to color coordinate these. Okay. We have, so we've already seen the word transversal. It's just a line that crosses two or more other lines. So in this example, it's line T. With our new words down below, notice that we already see the words interior and exterior. We already see those, so we've already covered those. So what's new then is alternate. Alternate means to lie on opposite sides. Okay, so alternate means to lie on opposite sides. Same side means to be on the same side of the transversal. So alternate means to lie on opposite sides of the transversal, and same side means to lie on the same side of the transversal. So, and then corresponding is a tricky one. Corresponding means to match. So if I'm looking at angle 1 is in the upper left corner of this intersection. And so if I look at the other line, angle 5 is also in the upper left corner of that intersection. Corresponding angles are the trickiest. And then we have alternate interior angles. So I'm looking on opposite sides of the transversal, but on the inside. So if I look at angle 3, if I also look on the inside, but on the other side of the transversal, angle 3 and angle 6 are alternate interior angles. Angles that are alternate exterior angles, they lie on opposite sides of the transversal. So if I look at angle 1, again, I'm going to look on the other side of the transversal, but outside in angle 8. Same side interior. So I'm looking, if I look at angle 3, another angle that is inside 4, 6, and 5, but angle 5 is the only one that's on the same side. Okay, let's practice. So just by naming these, so a corresponding angle to angle 1, I want to look for an angle that's in the upper left-hand corner on the other line. So I'm going to say angle 3. An alternate means on the opposite side of the transversal, but inside. So angle 6. So I'm looking at angle 3 or angle 7, but angle 3 is on the other side. Okay. Alternate exterior. So alternate on opposite sides, but outside. So I'm looking at angle 1, opposite sides, but outsides, angle 8. Same side interior to angle 4. Same side interior. Let's change that to angle 3. Because angle 3 is on the inside. Same side interior to angle 3, so on the same side of the transversal, that'd be angle 2. And same side exterior to angle 1, same side exterior would be angle 4. Let's match some corresponding angles. So angle 2 is on the lower left side of the intersection, so angle 4 is on the lower left of the intersection. Angle 3 is in the upper left, so that'd be corresponding to angle 1, and angle 4 would be corresponding to angle 2. Okay. All right, you try, and we'll see you in class.